Hey, all you MRWC fans, this is Mr. Ainsworth. We're going to get into a review on complex numbers, okay? And so before we get into Section 5, because Section 5 deals with complex numbers, all kinds of aspects of it, and as well as some trig and everything too. So it's a pretty cool section, but challenging, so get ready. So here we go. Let's talk about the set of complex numbers here. So in our previous sections here, we were talking about the rationals, the irrationals. Section 3 was all irrational numbers, which are all real. Okay, so what we're going to do today is we're going to take the real numbers here, the set of reals. Okay, the set of reals denoted by the capital R symbol. Okay, and real numbers, again, they could be rational or irrational. So some examples of some reals are 4, root 2. They could be rational, so 2/3, let's say. 4 is rational as well. They could be negative as well. So you can have, let's say, negative 1/5. Those are all real numbers there, whether they're rational or irrational. And in general, we're going to call them A. A represents any real number here. And then we're going to take a look at the imaginary numbers, okay? The imaginary unit, I. So imaginary numbers, and we're going to call them BI. Okay, BI, where B is the coefficient of I. So the imaginary unit is I. So what do these look like? Well, you can, for example, you can have numbers like 2i. You can have a root in front as well. So negative root 3i. Or you could be fractional. B could be fractional. It could be a rational number like 4/5 or 4/5 I. And whenever you take a real number and add or subtract it to an imaginary number, you get what's called the complex number. So complex, we're going to denote it by the capital C with a line through it here. And the form of any rational number, any complex number, is A plus BI. And remember, this B can be negative. So this is whether you add a real with imaginary or subtract a real with imaginary, it doesn't matter. The complex form is A plus BI. So, for example, if I take 4 and add it to 2i, I can take this real value and add it to the imaginary value. I get 4 plus 2i. That's an example of what's called a complex form or complex number. Or I can take root 2 plus 2i. That's another possibility, because they could be radical, they could be irrational. So root 2 plus 2i, that's still a complex number here. You can take 2/3, subtract root 3i. So 2/3 subtract square root of 3i. That's still complex. Okay, so when you take a real number and add or subtract it to an imaginary number, you get what's called a complex number, which is the biggest field of numbers that we have at our level in our mathematics. Okay, so whether you add or subtract a real with imaginary, you get what's called a complex number. So what we're going to do is we're going to play with them. We're going to play with the operations with complex numbers here a little bit. And the first thing we're going to do is we're going to add them, and then we're going to subtract them and kind of play with it. It's actually quite simple. So we're going to denote Z as our complex numbers, and the subscript right here denotes which complex number we're talking about. So our first one, we'll call it Z1, and the second number, we'll call it Z2, and if we had a third one, we'll call it Z3, and so on. So this is just the name of the complex number, the first one and the second one. So Z sub 1 is A plus BI, and Z2 is C plus DI. These are just two different complex numbers, and we're going to first add them. Okay, let's see what happens. And then after that, we're going to subtract them, because you see the minus sign right there. Okay, so there we go. Let's go right into it. Let's take Z1 and add it to Z2 and see what happens. All right, so if we take A plus BI, plus now, because we're adding, so plus, plus the second complex number, which is C plus DI right here. So notice that we are adding, okay? We're adding these complex numbers. Well, what we have to rely on, let me rewrite this here. What we have to rely on is our knowledge of Algebra 1, okay? We can only add like terms. Okay, so the key on this one here, let me put it up top, is to add like terms, okay? Something very, very simple. So add like terms. That's the key concept when you do this, okay? So what are the like terms? Well, let me see. I have the real parts here. So A and C are the real parts. So let's group them. Let's regroup here. So I'm going to take A plus C, and then I'm going to regroup the other terms. Here I'm talking about the BI plus CI, the imaginary terms. Okay, so these two, I'm going to regroup those. So I'm going to take BI and add it to DI. So from here to here, I just regroup. Okay, simple. Group up the reals, and then you group up the imaginaries. Okay, so A and C are unlike, so I can't really do anything with them, so I'm just going to leave it as such. Okay, but notice these imaginary terms have I involved, and so we need to factor out the I. And so what I do is I write it as B plus D, all right, times I. So I factor out the I. Factor out the imaginary unit. Okay, and this is complex form. So this portion right here is the real portion, or you can just say real. And this right here is the imaginary unit. The imaginary part. So it has a real part and an imaginary part. Okay? So you add the real parts together, then you add the imaginary parts together. That's all you do when you add complex numbers. That's why I said this part is pretty basic, as long as you understand one basic concept. And that is to simply add like terms. Okay? Okay. Now, in the next one here, same thing really happens, okay? So Z1, all right, is A plus BI minus the second complex number, C plus DI. And notice that I put the second complex number in parentheses, because when you subtract a binomial, you have to distribute through the negative, okay? So you subtract here, and then before you subtract C plus DI, you got to distribute through. Okay, so distribute first. Okay, you guys know how to distribute. So you got to distribute through the minus sign or subtract both terms. Again, these are just Algebra 1 ideas. So you subtract the C and you subtract the DI. Nothing hard there. Okay, so now you regroup. So from here to here, from this step, the next step is to regroup and then add like terms. And so regroup like terms. Here we go. So adding or regrouping the real parts, and I see A and the minus C. That goes first. Okay, you group up the real parts. So A minus C. And then you group up the imaginary parts, plus BI minus DI. That goes next. Okay, so plus BI minus DI. So I regroup the parts, so like terms. The reals with each other, the imaginaries with each other. Okay, and A minus C, nothing could be done there just because they're unlike, all right? You know that from Algebra 1. And here they both contain I, so they have something in common. So let's factor out the I, and we're going to have B minus D times I. So factor out the I's from here to here, that's what I did. Factor out the I. Okay, and this is called complex form. A minus C is the real part, and then B minus D times I. That's the imaginary part. Okay. Now remember, this is a video, guys, and in videos, whenever you listen to anyone, it doesn't really matter who it is, because it's a video. You have to remember that you can pause and play and go at your own pace, and that's what I expect everybody to do, because sometimes it's hard to write and think all at the same time, and if you're a slow writer, well, then that makes it even more difficult. Okay, so make sure that when you go through this video here that you pause and play and go at your own speed. Okay, go at your own speed. Okay, so just remember that it's a video, use it as such. Okay, now this is where you practice. Okay, so I'm going to model something and I'm going to have you try something. So we're going to pause and play through this part of it here. Okay, so when you add or subtract complex numbers, okay, once again, you regroup and simplify. So the first thing I'm going to do when I see these things, is I know that I'm adding. Okay, so it says plus right here. So this means you add these numbers here, and you take the real parts and you add them together. So I see 2 plus negative 3. So 2 plus negative 3, there's your real parts. And then I'm going to regroup here the 5i and the 8i. So 5i plus 8i. And then typically, you know, when you get good, you skip this step and you do it in your head. 2 plus negative 3 is just negative 1. So you add the real parts and you get negative 1. And then you add the imaginary parts, and 5 and 8 is 13, so you have 13i here. So you regroup, okay, and then step 2, you simplify. All right, step 1, step 2. It's that simple. So regroup and then simplify. All right, now pause the video right here. Pause it right now and then try part B. And then press play when you're ready. All right, so let's check your work. I see negative 6 and then a plus the 2. So I have negative 6 plus 2. I'm going to regroup them. And then I see a plus I and then a minus 9i. That goes next. Okay, so plus I minus 9i. So I regroup the real parts. And then I regroup the imaginary parts, and then I just simply add them together. And 1 minus 9 is negative 8, so I get negative 4 minus 8i. And that's how it's done in addition. Okay, so here where you're adding, this one, you know, with the plus sign obviously means you add. Here we're subtracting. Okay, so when you subtract complex numbers, you basically have to use the distributive property, and you got to distribute first. Okay, so distribute first. So let me model this here. Okay, so what we have negative 1 plus 4i first. Drop the parentheses there. Going to distribute through the minus sign. So we have a minus 3 and minus 7i. So I distributed first. On that step, there we go. And then what you want to do is regroup. So I see a negative 1 and a minus 3. That goes first. You got to regroup the real parts. And then you have to group the imaginary parts. Okay? So you have a plus 4i, and then you have a minus 7i. So you regroup like terms. And then you simplify. So distribute first, then regroup, and then you simplify. So here I see negative 1 minus 3, right, which is negative 4. And here I see 4 minus 7, which is a negative 3. So you get a negative 4 minus 3i. So step 1, you distribute. Step 2, you regroup. Step 3, you simplify what you see. All right, now pause the video. You try it, okay? Always pause and play, go through the video. Okay, let's distribute first. So I'll drop the parentheses on the first one here, and you distribute through. Okay, you got to subtract both of them and keep track of your signs. So what do I have? I have a minus 1 and then a plus 3i. A negative times a negative is a positive. If you subtract what's already being subtracted, you add. Okay, regroup. So 4 minus 1 and then a minus 5i plus 3i. You regroup and then you add. 4 minus 1 is 3. Negative 3 plus 5 is negative 2, so you have a minus 2i. Okay, so you distribute, you regroup, and then you simplify. Okay, step 1, step 2, step 3. That's all there is to it when you either add or subtract. Okay, you just simply add like terms. So going back to the very beginning here, when I first started, that's what I said earlier. The key on all of this, whether you're adding or subtracting, it doesn't matter. You add like terms. All right, and if you step it out, well then it's a piece of cake. Okay, now let's switch to products. Okay, products of complex numbers. Product means you multiply, obviously. All right, and what you need to know when you multiply, you need to know what I squared is equal to, and I squared is equal to negative 1 by definition. Okay, so we better highlight this right here. I squared is equal to negative 1, and if you square root both sides, some of you guys might know it as this right here. The square root of negative 1 is equal to I. Okay, so either one, they're the same thing. But if you know that I squared is -1, then you can multiply all of these complex numbers together, and it's pretty straightforward. So let's go for it here. And again, I'll pause and play through this portion of the video here. So go at your own speed and pause and play. So let me multiply here, and let me model the first one here. So 4 times -3 is -12, and then 4 times 8i is 32i. And so you have a real part with an imaginary part. So there's your complex form. All right, this is complex form right here, a plus bi. Complex, what's called complex form. And it's that simple, okay? Now pause and play through the video. You try the next one. Okay, so let's check your work on this one here. All right, so 5i times 7 is 35i. 5i times a -3i is -15i squared. So what do we have? We have 35i minus 15 times -1. That's the same thing as 35i plus 15. And then you switch the order. 15 plus 35i. There is complex form right there. Okay, so the real part comes first, and then an imaginary. Remember, a represents your real part, and then the bi is the imaginary part. Okay, real plus imaginary. Okay, now when it comes to multiplying binomials, you can use distributive property or FOIL using that acronym. It doesn't matter, it's all the same thing. So it's totally up to you how you want to think of it. But, you know, FOIL is distributive property. So I'm going to write down both. Okay, so that's the key on this one right here. So I'll illustrate the first one. So let's get started. We've got 2 times 1, which is 2. 2 times a -3i, which is a -6i. Multiplying through the 4i, we got 4i right here. 4i times 1 is 4i. And then 4i times a -3i is a -12i squared. So let's see what we get. We get 2, and then -6 plus 4 is a -2, so -2i. And then this is a -12 times -1, or -12 times, yeah, because remember, I squared is -1. These two negatives cancel out. All right, when you multiply a negative times a negative, you get a positive. Okay, and then 2 plus 12 is 14, minus the 2i. Okay, so you just want to multiply or distribute. That's the key. So let's try that. Okay, what I want you to do now is try it. So let's go up to part D up here. Again, pause and play and go at your own pace here. Give it a shot, and when you're ready, press play, and we'll check your work. All right, so here we go. So 7 times 2 is 14. 7 times 3i is 21i. Negative I times 2 is a -2i. And then a negative I times 3i is a -3i squared. So what do we get? We get 14, okay, plus 19i, and then plus 3. Remember, this is a -1 right there. Okay, that I squared is -1, and -3 times -1 is +3. So the end result is 17 plus 19i. Okay, now when you square binomial, you basically do the same thing as what we just did in C and D. Okay, so this means this is equal to 2 minus 7i times 2 minus 7i. Okay, you just don't square the terms inside. Okay, or you can use structure. You can square, multiply, double square as well. That's how I do it. I'll talk about that in the next one. So when you multiply through here, again, you use distributive property or FOIL. So one more time. So here we go. So 2 times 2 is 4. 2 times -7i is -7i. Excuse me, -14i. 2 times -7 is -14. Sorry. And then you distribute through the negative 7i, and you get negative 14i again. And then when you take negative 7i times itself, you get plus 49i squared. So what do you get? So you get 4 here, minus 28i, and then a minus 49. Because again, this right here, this I squared is negative 1, and 49 times negative 1 is negative 49. So be careful there. And then you get 4 minus 49, which is negative 45, minus 28i. And there's your complex form. Okay, so I want you guys to try it here first. The very first thing you do is you take 5 minus 3i and multiply it by itself. Or you can use structure. You can square, multiply, double square if you remember how to do that. Totally up to you. So you don't have to write it out like this. If you know structure, you can do it that way too. You can square, multiply, double square. And you'll get the same result. Okay, pause the video at this point and go for it. Okay, let's check your work. Here we go. So 5 times 5, 25. 5 times negative 3i, negative 15i. Distributing through in the middle here. So negative 3i times 5 is negative 15i. And then negative 3i times negative 3i is positive 9i squared. So you get right here 25 minus 30i, and then a minus 9. 9 times negative 1 is negative 9. And so 25 minus 9 is 16, and then the minus 30i. And there's complex form. Okay, so you gotta be good at all the different operations. Okay, so we did adding and subtracting first in the first set of operations right here. Key concept there is you simply add like terms, real with real, imaginary with imaginary. Then we talked about how to multiply complex numbers, and you need to know that I squared is negative 1. So when that happens, you just make that little substitution in your mind. And the next thing we need to do is talk about conjugates in order to be able to divide complex numbers. Okay, so what is the complex conjugate? So the complex conjugate has a certain symbol right here, z bar. That's how you say it, or the conjugate of z. Okay, so the complex conjugate of z bar is obtained by changing the sign of the imaginary part. Okay, not the real part, the imaginary part. So in other words, right here, given z is a plus bi, the conjugate of z, z bar, is equal to a minus bi. Okay, so notice that if you're given a complex number here, okay, the complex conjugate is simply you interchange from plus to minus or minus to plus. You change the sign, okay, of the imaginary part, not the real part. Notice a is the same on both of those. Okay, so let's get some used to that. Okay, here we go. So given this z, the complex number z, it's 1 plus 3i. Its conjugate is 1 minus 3i. So notice the change. Okay, you go from plus to minus. That's it. Okay, you change the sign of the imaginary unit. This is the imaginary part here. And it went from positive 3 to negative 3. So notice the change. Okay, that's all you do. It's very simple. You just go from plus to minus or minus to plus. Now, let's see what happens when you multiply conjugates. This is an important fact right here. So what we're going to do is we're going to take 1 plus 3i times 1 minus 3i and see what happens. So let's do that. So 1 plus 3i times 1 minus 3i. And we're going to multiply. And again, whenever you multiply like terms, you use FOIL or use structure. Okay? You can use structure as well. Okay, you could use the difference of squares. So a plus b times a minus b equals a squared minus b squared. You could use that. So you could use structure if you want to. I'm just going to multiply through. So here we go. So 1 times 1 is 1. 1 times negative 3i is negative 3i. Three I times 1 is positive 3i. And then 3i times negative 3i is negative 9i squared. These terms in the middle cancel because they're opposites. And so you get, what do you get? You get 1 minus 9 times negative 1, which is 1 plus 9, or 10. Okay? You get 10. You get a real number. This is a real number. Does that always happen? I don't know. Let's find out. Let's take a look at another example here. In fact, you know what? Pause the video at this point. Write down the conjugate and then multiply the complex number and its conjugate together and see what happens. Let's see if you get a real number. All right, pause the video at this point. Okay, so I'm assuming you're pausing and playing here. Let's check your work. So the conjugate now, okay, of z is negative 5 plus 8i. Again, you go from minus to plus. That's all you do. And the real part stays the same. So here when we take this product right here, negative 5 minus 8i times negative 5 plus 8i, what happens? Do you get a real number? I don't know. Let's find out. So let's go ahead and multiply here. Negative 5 times negative 5 is 25. Negative 5 times 8i is negative 40i. And then here we have negative 8i times a negative 5, which is 40i. I'm going to put a plus sign because it's positive. And then 8i, negative 8i times 8i, and that's a negative 64i squared. So what do you get? Well, you get 25 here. These cancel. I don't know why it's doing that. Sorry about the screen flashing there. So these cancel to 0. Negatives always, or opposites always add to 0. So you get 25 minus 64 times negative 1. That's 25 plus 64, and that's 89. Holy cow, we got a real number again. So when you multiply conjugates, it seems like you always get a real number. You don't get complex. So the question is what happens? Do you always get a real number? Well, let's find out. Let's take two general conjugates and multiply them together and see what happens. So let's take a plus bi, which is z, right up here. Its conjugate is a minus bi, so let's multiply them. And let's see what we get. All right, so here we go. So a times a squared. A times a negative bi, so negative a bi. Inner product here, bi times a is a bi. And then here, bi times a negative bi is a negative b squared times I squared. Okay, so what do we get? Well, these terms in the middle cancel. And I see a squared right here. So a squared minus b squared times negative 1. Remember, this every time you see an I squared, you get negative 1. So you get a squared minus b squared times negative 1. These cancel the signs. All right, negative times a negative is a positive. So let's switch to addition here, and you get a squared plus b squared. And as you guys know, a real number squared plus a real number squared gives you a real number. So this is always a real number, always. So the question here, the question that I pose to you is what type of number results? What type? Okay, and guess what? A squared plus b squared is always a real number. So when you multiply conjugates, it's always real. That's an important fact. It's always a real number because we know that the set of reals are closed under squaring and addition. A real times a real is real. So a times a. So a times a gives you, real times a real equals a real. And the same thing with b. B squared is b times b. And so b times b is the same thing. It's real times a real gives you a real. And then, of course, a real plus a real is also a real. So a real number, all right, plus a real number is equal to a real number. All right, so this right here, when you multiply conjugates, you always ends up being a squared plus b squared, and that's the structure of it. That's the quick way to multiply conjugates. You just square both and add. Okay, so you square both Oops, gotta spell that right. So square both and add the results. Okay, that's how you multiply conjugates. Okay, square both and add. Easy. Okay, so we're going to use that fact. Okay, so here we go. Check this out. Now we're going to take a look at a quotient. Okay, a quotient. Quotient right here, as you guys know, is A divided by B. Okay, it's a rational number. So, but we're going to take a look at complex or quotients in complex form. Okay, so how do we get this quotient in complex form, where we have a real part, all right, plus an imaginary part? Okay, well, these first two are easy when the denominator is just a monomial, just a single real number. Okay, so on this one here, let me model here, you just take both the real and the imaginary parts and divide them both by 4. So in other words, you take 1 divided by 4, and then you take the imaginary part and you divide it by 4. Divide both by 4. That's the key concept here. So divide both by 4. Okay, and so you get 1 divided by 4 plus 3i divided by 4. My friends, that is in complex form, a plus bi. So a is 1/4, that's the real part. The imaginary part, okay, is 3/4 i. So b is 3/4. And that's all there is to it. Same thing here. So you're going to take both the real and the imaginary parts from 8 minus 5i and divide them both by 2. Okay, so let's go ahead and pause and play now again. Again, work with me here, guys. Just go ahead and pause the video whenever you're ready, and then perform the operation, and then press play and listen to my response, and let's check your work. Okay. All right, so we're going to divide them both by 2 now. So 8 divided by 2, and then negative 5i divided by 2. So 8 divided by 2 minus 5i divided by 2 gives you 4 minus 5 halves I. And I want you to leave it improper. Okay, that's typical. Okay, and that is complex form. A minus or plus bi, where in this case b is negative. B is negative 5 halves, and then a is 4. There you go. Now things do get a little bit more challenging, because when the denominator is complex, the question is how do you get it in complex form? So using the conjugate of the denominator here, express the quotient in complex form. All right, so the given complex numbers are not in complex form, all of these examples right here. All right, the goal is to express each number in complex form, because right now they're not. It's not something, real plus imaginary. This is a quotient, not a sum. All right, so remember, the complex form right here is a plus bi, and these fractions here are not in that form. So the question is, how do you do that? So what we're going to do is we're going to take the conjugate of the denominator. So this is the key, using the conjugate of the denominator, not the numerator, the denominator. All right, so here we go. We've got our given complex number, z, is 2 divided by 3i. That's called a quotient. So I'm going to take 2 divided by 3i, and I'm going to multiply it by its conjugate in red. The conjugate of 3i is negative 3i. So I'm going to multiply it by negative 3i up top and negative 3i down below in the form of 1. Okay, negative 3i divided by negative 3i is just 1. Okay, this is called a form of 1. And that's why it's legal, by the way. You can multiply any number by 1 and it doesn't change the number at all. It may change the way it looks, but it doesn't change the actual number itself. Okay, so just keep that in mind. So that's why it's legal. 2 times negative 3i is just negative 6i. And then 3i times negative 3i is negative 9i squared. And then we have negative 6i divided by negative 9 times negative 1. Because remember, I squared is negative 1. Right here, I squared is negative 1. And then you simplify. And so we get negative 6i divided by 9, which is just negative 2/3 I. And that is in complex form. Okay, that is in a plus bi form. Just b is a fraction, but it's no big deal. Okay, and there's 0 is a real part. There's no real part in this case. Now there is a slightly different way you can do it that might be a little bit easier. So when you have only an imaginary part and not a full complex number where you have a real plus imaginary, another way you could do it, we'll do it down here. Okay, so I'm going to put down or. This is method number 2. If you take 2 divided by 3i, really you only need the imaginary unit. So watch this. I'm going to just multiply by I over I. Sometimes you can get creative and do things in an easier fashion, and I'm showing you this. Okay, this is method number 2, and you'll get the same result. 2 times I is obviously 2i, and then 3 times I is 3i squared. So the numerator is 2i, and the denominator is 3 times negative 1 or negative 3. So you'll notice that you get the same value. So negative 2/3 I. So notice these are the same. Okay, so whether you do it the first method or the second method here, it doesn't matter. You end up with the same result. Okay, the first method I used the actual conjugate. The conjugate of 3i is negative 3i. So you could use that every single time. But as you can tell in this little example here, the first method is a little bit longer, I think, a little bit more tedious than the second method. So when it comes to like simple expressions like this, where you only have the imaginary unit down below, I like the second method better than the first. Okay, so pause the video. Again, pause and play here. All right, just don't be robotic and take notes, okay, and copy. Interact with me. Okay, pause the video and give it a shot. Number 8. Okay, so let's check your work here. So we're going to take 8 divided by negative 5i, and I'm going to use method number 2. I'm just going to multiply by I over I, and I get 8i up top, obviously. 8 times I is 8i. I get a negative 5i squared down below, and that's 8i divided by negative 5 times negative 1, which just simply gives me 8i divided by 5, or you can write it as 8/5 I. It's the same thing. So this is pure imaginary. Pure imaginary. There's no real part. Okay, when there's no real part and there's only an imaginary part, it's pure imaginary. So a is 0 in this case. Okay, but that's complex form right there. Now, when it comes to binomials, and when you have a full complex number down below in the denominator, then you have to use the conjugate, the full conjugate. So here we go. All right. The conjugate of 1 plus 3i is 1 minus 3i. So I'm going to multiply this by 1 minus 3i up top, and then 1 minus 3i down below. And I'll put parentheses around everything because these are now binomials. So distribute through up top. So 5 times 1 and then 5 times the minus 3i. So I get 5 minus 15i up top. And then down below, you could multiply using FOIL, you can, or you can use structure. Okay, so to make this really, really fast, you just square both and add. Let me go back to this right here. So whenever you multiply conjugates right here, it's always equal to a real number, and the real number is found by taking both a and b, which are your numbers in the complex number right here. Okay, you square both and add. That's what I was saying right here. You square both and add. That's the fast way. That's by using structure. That's the structure of it. It's always equal to a squared plus b squared every single time. And if you can't remember that, then you have to use FOIL every single time. Okay, now what I'm going to do is you take a, so a is 1 and b is 3. So it's a squared plus b squared when you do this. Or you can use FOIL. 1 times 1 is 1. 1 times negative 3i is negative 3i. And then 3i times 1 is positive 3i. And then 3i times negative 3i is just negative 3i, excuse me, negative 9i squared right here. The terms in the middle here, these terms right here, they're going to cancel to 0. So you get 5 minus 15i up top divided by 1 plus 9, 1 plus 9. So I think taking a and b and just squaring both like this using structure, I think using structure is much faster, especially after you get the hang of it. Because 1 squared is 1, 3 squared is 9, and you get a total of 10. Alright, so this is equal to 5 minus 15i divided by 10. And then if you divide both by 10, you get 5 tenths minus 15i divided by 10. So the last step here, we get 1 half minus 3 halves. Divide, you simplify your fractions, so minus 3 halves I. And that is complex form. Okay, so I showed you using FOIL first from here to here. I use FOIL first, but if you use structure, it's faster. Using structure is faster. Okay, but it's totally up to you. You could use FOIL and distributive property every single time, but these middle terms will always cancel out, and you will always end up with a real number. So I just square both and add. Okay, let me write it down again. So square both and add. That's the structure behind multiplying conjugates. As I said back up here, oops, I'm sorry, right here. So what happens when right here, what happens when you multiply any two conjugates? Well, you always get a squared plus b squared. So you just square both and subtract, square both and add, excuse me, a squared plus b squared. Square both and add. That's the structure behind multiplying conjugates. It happens every single time. Okay, at this point, and it's now your turn. Okay, so pause the video and try number 10. All right, let's check your work. Okay, I'm going to multiply by the conjugate here, so I'm going to put a multiplication symbol here. And the conjugate of 2 minus 5i is 2 plus 5i. Put binomials around each one, or parentheses around each one, and distribute through up top. So you get 6 plus 15i. And then here, this is a and that's b. And then remember, a, when you multiply conjugates, because we're dealing with I now, which is a unique imaginary unit here, when you multiply conjugates, you square both and add. Okay, so square both and add. That's the key. That's how you do it quickly. So 2 squared plus 25, excuse me, 2 squared plus 5 squared. So 2 squared plus 5 squared. So you get 6 plus 15i divided by 4 and 25 is 29. And so you divide both by 29, you get 6 29ths plus 15, 29ths I. Okay, there's your complex form. Again, you just divide both terms by 29. That's all I did. You split the fraction. Okay, you split the fraction. Okay, now you try it on the next one here, number 11. Pause and play. Okay, let's check your work. We're going to multiply this by 1 plus 2i. 1 plus 2i. Here we go. So what do we get? Z is equal to 3i plus 3i times 2i is 6i squared. And then here, a is 1, b is 2. So 1 squared plus 2 squared. So you get 3 squared minus 6. Okay, 6 times negative 1 is negative 6. Divided by 1 plus 4, which is 5. Okay, and then you divide them both by 5. So you get 3/5 I minus 6/5. And then I would switch the order, negative 6/5 plus 3/5 I. Okay, a plus bi form. A plus bi form. It's complex form. Okay, pause the video. Try number 12, the last one in this group. All right, let's check your work here. So I'm going to multiply it by its conjugate in the form of 1. Here we go. Again, put parentheses around all the binomials because you're going to distribute through up here. So what do we get? We get negative 2i times 4, which is negative 8i. Negative 2i times a negative I is plus 2i squared. And then here we get 4 squared plus 1 squared. Okay, so we get a negative 4 here, minus 8i. I switched the order on you right there. 2 times negative 1 is negative 2. Ooh, why did I say negative 4? I meant negative 2. And then I wrote it in complex form, so I switched the order there. And then 16 plus 1 is 17. And then all you do is divide both by 17, so you get negative 2 17ths, and then minus 8 17ths I. All right. Now, let's see where we're at here. Okay, so now what we need to do is just kind of play with the imaginary unit and take powers of I, starting with I squared, starting with what you know. So this is what we know. When you do this, when you take powers of I, there are patterns. So I want you guys to look for patterns when we do this. Okay, so I squared times negative 1. Or excuse me, I squared equals negative 1. Now to get from I squared to I cubed, you simply multiply it by I. That's all you do. So negative 1 times I, guess what? That's called negative I. To get from I to the third times, to get from I to the third to I to the fourth, you have to multiply by I again. So times I again. So here you get negative I times I. Well, that's negative I squared, which is positive 1. So I squared is negative 1. So negative 1 times negative 1 is a positive 1. This is one way you can do it here. But there are patterns. There's other ways to do it too. This is positive 1. And then times I again. To get to I to the fifth, you got to multiply it by another I. So 1 times I is simply I. And then there's certain patterns that are going to go on here. Now to get from I to the fifth to I to the sixth, you got to multiply it by I. So I times I will give you I squared, which is negative 1 again. So now we're back to negative 1. And then times I. So negative 1 times I is negative I. Again, you just multiply it by I each time to get to a higher power. So negative I times I is a negative I squared, which is 1. Look at that, I went from negative 1 to negative I to 1. On the previous one, negative 1 to negative I to 1. Then again, you multiply it by I. So you get 1 times I is I. Oh, so we get the same 4 as the first 4. Does that keep happening? To get to I to the 10th, you multiply I to the 9th times I. So I times I gives you I squared, which is negative 1. And then times I, you get negative I times I, negative I squared, or 1. And then 1 times I is I. Holy cow, the pattern repeats itself. Negative 1, then negative I, then 1, then I. Negative 1, then negative I, then 1, then I. Those are the only possible results. And look at the even powers. Even powers go from negative 1 to 1 to negative 1 to 1. I'm talking about the even powers here. The second, fourth power, sixth power, eighth power. In fact, let me just highlight them. Okay, so here are the even powers. Okay, when the powers are even, you get either 1 or negative 1. So even powers. Okay, the result is either positive 1 or negative 1. Okay, or you can say plus or minus 1. Plus or minus 1. And the odd powers, well, what do you get? Well, let me see. You get, let me see, negative I and then positive I. Negative I and then positive I. Negative I and then positive I. So it's plus or minus I. Are there more patterns? Can you figure this out? Let's say if we take it to the 100th power, let's say, are there ways to figure that out? And the answer is obviously yes, because there's always cool things you can do in mathematics. We'll talk about that later. Now the last thing I want to talk to you about is how to graph complex numbers using what's called the Argand diagram. This is the guy who came up with this, okay? Mr. Argand. And so it's fairly straightforward, but instead of having the typical real axes, the x and y axes, we're going to call the horizontal axis the real axis, okay, A. And then the vertical axis, instead of calling the y-axis, we're going to call it the imaginary axis, okay, I. Okay? And so what we're going to do is, given these complex numbers in complex form, which is a plus bi, we're going to interpret that as an ordered pair, a comma b. So for example, 7 minus 3i can be interpreted as 7 comma negative 3. So you go 7 to the right on the real axis because it's positive. So 1, 2, 3, 4, 5, 6, 7. So just extend it. Let's extend it here. 6, 7. So 7 is right about here. So we're going to go 7 right and then down 3. So 7 right, down 1, 2, 3. There you go. And that would be the position of 7 minus 3i. Because we went right 7, down 3. And again, this is not the x-axis, it's the real axis. Okay, it's the real axis, A in general, and then we've got the imaginary axis up here with the imaginary unit. Okay, and then the next one here, how do you graph negative 5 minus 2i? So we're going to interpret that as negative 5 comma negative 2. So you go to left 5 down 2. So left 5 down 2 be right here. This would be B. Over here, this would be A, the first one. For 1 comma 3, 1 plus 3i, we interpret it as 1 comma 3. So we go 1 right, 3 up. So C would be right up there, 1 plus 3i. And then negative 4 comma negative 2, or negative 4 minus 2i would be interpreted as negative 4 minus, comma negative 2. That's left 4 down 2. So left 4 down 2 would be right here, and that'd be D. Now, E is purely imaginary, so I can rewrite this if I'd like. Okay, this is equal to 0 minus 3i. So I'm going to interpret this as 0 comma negative 3. So 0 comma negative 3 is right here, and that would be the location of E, which is just pure imaginary. So you're going to be on the axis there. Now F is purely real. So this is 4 plus 0i. So I'm going to interpret that as 4 comma 0. So you simply go right 4. You're on the real axis because it's purely real, and that's where F is. Now G is pure imaginary. So I can rewrite this as 0 minus I. And so I'm going to interpret this as 0 comma negative 1. 0 comma negative 1 is just down 1 on the imaginary axis there. So G is down 1. And then H here, change that to H. Okay, I is the same thing as 0 plus I, so I can interpret that as 0 comma 1. So you got to go up 1, and there's where H is. So when you graph imaginary or complex numbers, it's pretty much the same way as the typical coordinate plane. But instead of the real axis, or excuse me, the x-axis on the horizontal, you have the real axis denoted by A. Okay, and then instead of the y-axis vertically, we have the imaginary axis. Now you've seen all of this stuff. Everything I've gone through today, you've seen in Algebra 2. Okay, this is part of the Algebra 2 curriculum. So I have not done anything new. This is a review of Algebra 2 on complex numbers. And then you're going to, through our program here in MRWC in Section 5, we do all sorts of things. And we dig a little deeper here in MRWC. We're going to figure out all kinds of things about what we've just talked about. Okay, so we're going to go a little bit further. Okay, so this is just it's an introduction, but it's mainly a review from Algebra 2 to get you ready for Section 5. Okay, this is Section 5 coming up in the MRWC program here. All right, I'm Mr. Ainsworth. I can't wait to work with you later on in future activities. But right now, remember, this is a video. Go back and pause and play, go at your own speed, and practice and get good, because you're going to use all these skills in Section 5. All right, I'll see you then. Bye-bye.